So again, welcome. This is our first talk of the new year, 2019. Again, I'm Bryan Jones, build engineer, formerly an app DBA, senior DBA. My co-speaker, Matt Thomas, principal system engineer, UI. And I guess, tonight we're going to be talking about JSON and relational databases. So let's dive in. Oh, I guess before we do, some of you that have been here kind of know the format. Consider this a guided discussion. We have slides and obviously we have a agenda, but feel free to chime in with questions. You can raise your hand if you want or just yell out. Try to be somewhat friendly and just kind of a back and forth. So don't feel like you're disrupting the flow of the cadence or anything like that. So, and I am not an expert on database stuff. So to Matt's earlier point, this is a learning experience for me as well, just learning how to use JSON within the relational database confines. So, you may know something that I don't. Again, feel free to chime in and help the cause or help clarify a point that one of us maybe make that doesn't quite hit the mark. It's all good. So we'll start off with just a kind of a brief high-level historical overview of relational database history and how we got to where we are now. So, since 1970, I think, is when the IFCI came up with this database paper about relational databases and the fundamental principles that underpin those, based on relational algebra and set theory, which was kind of revolutionary at the time, using sound mathematical principles to create a database. That was something that wasn't really done back then. And relational databases provide storage, functionality, memory, help with our memory needs, data, metadata, and also a independent query language to access data, things that we take for granted now, but in 1970 and the 70s, that wasn't necessarily the norm. So there was data before relational databases, before 1970, they existed maybe in flat files or in hierarchical data or in network data, and they had their own pros and cons, and what the relational database did was to try to address some of those cons, like with duplicate data, inefficient searching, trouble decoupling query code from the actual physical layout of data on disk. That was all stuff that some of these more popular database formats dealt with, and so relational databases help to kind of minimize some of those issues. Some of the core concepts or goals of relational databases, a big one is avoiding data anomalies, so data duplication, data inconsistency, really focusing on the integrity of the data. So if you retrieve some data, you can be sure that the data that you retrieved is the correct data that you want. Normalization, which is a set of rules that if you follow, you can have a properly designed database that will help you eliminate redundant data. That was a tenet of relational database design. Atomicity, consistency, isolation, and durability, or ACID is the known acronym. These are principles of relational databases that if a relational database system, management system offers ACID functionality, it really helps with data integrity. And so the quintessential example is the bank account transfer, where person A wants to transfer $100 to person B. If you have an ACID database, you can be sure that that $100 will actually make it to the person B's account, or if something were to happen in flight, the $100 wouldn't just disappear, or you wouldn't have a case of where $100 was in person A or person B's account at the same time, which would be nice, but that would be poor data. So the point I'm making is relational databases are really focused on data integrity, consistency, and it really helped with enterprise companies, especially in the US, but I guess worldwide, for the last 40, 50 years. So it was great. And the databases obviously over the decades got more powerful. The problem was around the turn of the century, we started to see the rise of these large scale internet companies, and they had slightly different data needs. And so, support for 10,000 plus concurrent users. That was something that, a lot of traditional enterprises maybe didn't necessarily deal with. Low latency response times in microseconds or milliseconds. Again, if you're an enterprise user, maybe you don't necessarily need response is quite that fast, but for your Googles of the world or your Amazons at the time or Yahoos, that was maybe something that they needed. High availability to serve all these concurrent users and horizontal scalability needs. Not that you couldn't do this with relational databases, but they weren't really designed from the ground up for that. And these companies were getting really big and had a large data footprint. And so what we started to see was the rise of a new breed of databases, NoSQL, which I'm sure most of you are familiar with, not only SQL. And it's just a different type of data structure from the traditional relational database that had been the rule and the roost since the 70s. And so you have four main families of NoSQL. The key values is a simple key and a value that's associated with said key. You have a counter database, which kind of pivots traditional data on its head, and it's really good for aggregation queries or analytical processing. Graph databases, which really focus on the relationships between individual records or nodes. In a relational database world, you have the concept of foreign keys, which allow you to relate two tables to each other via a common field. But that's not really a first-class citizen, whereas with the graph database, the relationships, the edges are first-class citizens. You can do a bunch of stuff with the actual relationship themselves. And then you have document databases as well, which really focus on embedding the joins, the traditional joins that you would see in a relational database. A document will say, okay, now we'll just take all that related information and put it all into one record, to where if you just hit that one record, you can retrieve all the related records without having to join a bunch of different tables together. Ironically, a lot of these these new NoSQL databases are actually throwbacks to the flat files and the hierarchical data systems that predated the relational database world, but obviously supercharged for a new century. So we're going to focus on documents today for our purposes. They're more complex than a simple key value database. A document essentially is a set of key value pairs, but more complex than just a simple key value pair. And usually the document is going to be stored in either JSON or XML. We're going to focus on JSON for tonight's talk. And you want to take, what is JSON?
So, is everybody familiar with JSON? Nobody not? So it's essentially just a way, it really only has three data structures. It has a string, well, four: number, string, object, and array. And essentially, pretty much any data can be stored in that, in a combination of those data structures. I don't know what else really to say about it other than it really allowed, XML it was supposed to be the end-all be-all to data transfer, and well, it was implemented in Java, so how the hell could that go wrong, right? This is much more flexible. It allows you to understand the data type you're getting back without having to have a bunch of metadata. So,
absolutely.
And it is the go-to format now for web transfer. So,
right.
Why you would want to use JSON in a relational databases? We have some use cases coming up that I don't want to really tromp on too much, but there are certain complexities involved in building or designing a relational database that maybe you don't need. There's indexing, there's primary keys, and there's foreign keys that are required to normalize your data that, and I'm a front-end developer by trade right now. I have a lot of experience in full stack, so I understand the complications of creating those databases. But as a front-end developer, I could give a rip about the data structure of the database. All I want you to give me back is the JSON I'm looking for, right? So there are certain instances where I want to handle my data, and I just want to hand it off to the back end to store until I need the data again, just to persist the data. Does that make sense? Well, now, I don't know if Postgres was the leader, which I'm still a little bit of your thunder too, but Postgres was the leader in seeing the vision in this mixed document versus relational databases. You can see there's some things that Postgres and MySQL have added in that allow you to really link those two pretty integral, and that's why we're here tonight. So.
Yep. So yeah, data modeling, traditional relational databases versus JSON, just to Matt's point. Again, relational databases, normalization, really focusing on data integrity, even at the expense of maybe the data query, the access times, maybe you suffer a little bit there, but your data will be stored on disk in proper format to minimize duplicated data, which will minimize data inconsistency. That's the focus of the relational world, whereas with JSON, denormalization, minimizing the need for joins and supporting flexible schemas. And so there is a kind of a mismatch contrast. What's up?
Good way. I watched this really cool video recently by the guy who works on MariaDB for Amazon.
Yeah.
It's a really good explanation of using a relational database is good when you want to have a lot of flexibility with how you query the data later, whereas using maybe a document store, a key value store is better for like raw performance, but you really it works a lot better if you know ahead of time like what the structure of your data is,
Yeah.
so you can set it up that way. So that's I thought that was a pretty insightful way to think about like where the benefits are.
No, it's an excellent point. Yeah, you're kind of hard coding your data access path. So yeah, for that specific use case, if a document data store suits the way you want to access the data, then that's probably better. But yeah, you're right. As soon as you want to query the data in a different way, you may find yourself, dealing with some issues. Oh, sorry, Shani, for stealing your thunder.
Well, and it also comes down to relational databases. The backend defines the structure of your data versus, like in the case I use most of the time. Me as a front-end developer, I'm defining the data structure and then just allowing the relational database to store it, or the document store in this case.
All right.
So,
Yeah, and with NoSQL, you're starting to see, and I guess tonight is a big indication of that. You're starting to see this two sides converging. All right, so we have Postgres and MySQL, MariaDB that are introducing NoSQL components and data types into the relational, kingdoms that they built. And on the flip side, you're seeing, databases like Mongo starting to offer SQL-like syntax. Cassandra's got their CQL, which is kind of a SQL-like syntax. And, I think that's just where the industry is going. You're going to start to see just this blob of this is just a database engine. There's really no relational, no SQL. It's just kind of serving your particular use case. So if you imagine you want to run ad hoc queries, then okay, you're going to maybe use more of the relational functionality. But if you are pretty confident that okay, said data access paths are going to kind of be set in stone for a while, then maybe we can start to look at different NoSQL solutions. And the beauty is, hopefully you can do it all in the same database. There's things like, I don't know if there's any database out there as of yet that offers relational plus all four of those NoSQL families. I know there's some that are closed. Postgres is closed, but I don't think Postgres offers like graph functionality. They've got, I think, something called Citus data, which is they fork Postgres and they do some graphing stuff with that. OrientDB is another that's a graph database, but also is a document store and also is some other stuff. But yeah, I definitely think that's the database world is starting to converge, which is pretty cool. Yeah. So we're gonna have some simple use case examples to kind of illustrate some of these points. Again, if you have questions or points of clarification, please just jump in. Relational versus JSON at the top, we've got an example of, so our FullStackers IO database, the back end, some of the tables are related to our talks and the URL resources that support these talks. And so we have 3 tables, a talk table, a resources table, and then in the middle we have an associated table where we join the 2 tables together via the foreign keys. And that's a properly designed relational design. And to the right of that, you see we have the query that we would use to actually extract the title and all the URLs associated with the talk, and maybe there's some voting, on the URLs. And you see we've got 2 of these joins and we've got these 3 tables, and that's not that big of a deal. But if we were hell-bent on minimizing that, we could store all this in one table, and we would essentially just have a resources column with a JSON-B data type, and this is for Postgres. Oh, it's an image. Can I do anything with that?
You can zoom in like a normal, it's just a web page, so.
Oh, can I? I didn't think I could. It's not, not on the
Nope.
images.
Damn it.
Shoot, sorry, Steph. I mean, all right, I will try to, I'm assuming you can't read anything? No, okay. Okay, all right. So yeah. We have a talk table.
If you want to follow along, you can go to where MariaDB
Oh, yeah.
codes, and these slides are up there as well.
You want me to pull that up, or
Sure, if you want to.
what am I typing?
Where MariaDB, there it goes.
There it is.
And then that top big JSON icon will take you to the slides.
There.
Yeah. There you go. If you want to follow along on your phone or on your computer, you're more than welcome.
Okay.
Where MariaDB codes, it's MATSINET.
Hold on. Is where dot?
Oh, where dot MariaDB dot codes.
We'll leave that up. If you have problems getting to it, just yell out for us to stop, and we'll go back to that and show you the URL again. But yeah, okay, so at the top we have a talk table. On the left, essentially just a talk title and a talk ID. So, RDBMS and JSON is the title, ID of 1. On the right, we have a resources table, resource ID, and then the URLs for the, different sources that we use to create this presentation. And then if we want to relate these 2 together, these 2 tables, we'll have a third associative table. And all this is a join table. So we're going to take the talk ID from our talk table, the resource ID from the resources table, and those 2 fields will comprise a primary key. And so that'll associate a given resource to a given talk. And so that's what's happening up at the top. And then next, we have the query that we would actually run to actually bring that information together. Down below, if we did not want to do that, if we really did not want to avoid joins, we could just put all that in the same table. So talk ID, a title, and then we could just have a resources data type or resources field with a JSON-B data type. And it's just a blob. We can just throw more complex data inside this, which goes against normalization and traditional relational database design. And you see here, this is the query that we would actually run to actually pull out essentially the same information. So the query is much more efficient, easier to read, and probably a bit more performant because you don't have these joins in there, and we have all this stuff in one table. So, a lot of pros here. There are still some cons, but just a pretty simple case of just showing the difference between third normal, proper relational database design, and then, seeing the NoSQL world kind of creeping in there.
And a disadvantage to this, or advantage and disadvantage to this would be, you could add anything you want to the resources JSON object. I'm sorry? Where dot MariaDB dot codes, MATSINET. If you're just claiming it for later, it'll be at the end of the slide. But where MariaDB codes, A-T-S-I-N-E-T. I wish this was a marker board.
It can be.
It is?
No, don't.
Give me my permit or a marker, I'll be,
Our last presentation in the room.
yeah.
Did you get it?
Here it is. When you got a name like Matt Thomas, it's hard to get.
No. There you go. Look at you. Fuck, are you kidding me? I just did. Is that it?
Yep. Everybody got it? Steph? Okay.
Cool. Yeah, sorry about the crappy images. Yeah.
So
yeah, what was
what I was saying is that the advantage is the bottom one using the JSON document as a column is you can be flexible in what data you store in that. That's also a con because when you go to query that column, you don't necessarily know what to expect when it's in what you're going to get back. If you query the whole thing, you might get back, well, I know of a case where you get back 5 meg worth of data. That's a hell of a chunk of data to transfer over an internet connection in an API request. You know what I'm saying? So you got to be careful. There's a lot of flexibility in it, but it's kind of like free speech. With free speech comes responsibility. You got to be careful what you. There's consequences to what you do.
Absolutely. So next, if we just if we continue this example, same talk and talk resource and resources table, but now we want to actually add the speakers to the query. What's up? Oh, okay, right on. So we're going to introduce 2 tables. We have a user table, user ID and username, and then we're going to have another join table called speaker, where we're going to take the user ID and the talk ID, and those 2. That's how we're going to join speakers to a given talk. So Matt and I would, have 2 records in our user table, and we would be associated with tonight's given talk. So you see the query on the right, essentially is the same query that we just looked at, but now we've introduced 2 more tables, and so 2 more joins. And the more, joins are great, they allow you to bring related data together, but the more joins you have, the more of a performance that you're going to take. And it just depends on how much data you have and your data types and all that good stuff. But, in the database world, and this is for NoSQL and regular SQL, less is more. So if you can minimize the amount of joins, minimize the amount of tables that are part of a query, minimize the amount of data, not 5 megs or whatever coming back across the wire, you want to do it. So down here, though, if we want to stick with our JSON alternative, all we did was simply add another speakers column with the JSON B data type. And our query to select is still essentially the same. All we did was we just added an additional column to our select statement, and we're off and running. With all the cons that Matt just pointed out, we don't technically know what's in this speaker field, but you see, as we increase these tables, if we want to start adding other information, you can see how this could start to really get cluttered. At 5 tables, it's not that big of a deal, but at 15 tables, 25 tables, you can start to see performance degradation, whereas the JSON route, maybe helps, under this scenario.
One of the other things that just popped into my head is if you wanted to get back this talk with all the speakers, but you only wanted 1 record, that query gets very complex real quick trying to figure that out, because by default that will want to return that talk twice with 1 speaker in each row. So, and that may not be what the result you want to be, returning back to whatever's asking for the data, right? You might want to just get back to 1 talk with 2 speakers associated with it, not 2 records. So you could see where that could get out of hand real quick after you start saying, well, there's 20 resources associated with this. Now I'm going to get back 22 rows, or maybe I'm going to get back
There'll be more than
40
40, yeah.
40 rows. And it's going to have each speaker with each resource associated, and now you got to start managing that. So you can see where this data structure might get a little bit hairy on normal relational databases, where in a document store, you're just going to get back an object with whatever data you need inside of it.
Right. And there are ways to whittle this down and morph it into the format that you want, but that's extra work that you have to do. And again, these databases are getting better at kind of offering that functionality in an easier way. But yeah, this is more natural to that. So under this narrow scenario, it looks like JSON, JSON-B, whatever could be the way to go.
And I'm a front-end developer, so take it from where it's coming from, okay?
No, I mean, your point,
No,
that query right there will return our 40 rows or whatever, and we don't
Right.
want that, So kind of extending the example, if we look at our user table, if we want to add some contact information to the user table, email, phone, LinkedIn, Twitter, Facebook, and populate it with, 4 users, this is, the table could look something like this. And, our contact, we're saying we're not going to require, every bit of contact info. And so you see we have some gaps in our data. A sparse table, again, with 4 records, not a big deal, but, 4 million, 40 million, you've got a bunch of, missing data or null values or whatever. That's not great, especially if you want to maybe alter the table in the future. If you want to add another column that is a not null, that could be very problematic. And it's just a very sparse table is kind of emblematic of maybe a subpar database design in the relational world. So ways to get around having this, and this is not JSON related, is database design pattern or anti-pattern called the entity attribute value. Is anybody familiar with this database pattern? Yeah, okay. Has anybody actually implemented? I haven't actually implemented. You have? Okay. Oh, there you go. Right. Yeah.
Exactly.
And so we have 3 tables up top. We have our user table on the far left, user ID, username. On the far right, now we have a user attribute table. And then in the middle, we have a join table that's going to associate a user to a given attribute. And essentially, this attribute table, every row in that attribute table is going to correspond to one of the email or one of the contact columns that we saw in the previous table. And what this allows us to do is to say, okay, we can now in our join table just have every record in this join table is going to correspond to a communication type that we saw in the previous table. So we saw Kenny had, he's a good guy. He had all 5 points of contact for us. So Kenny's going to have 5 records in this attribute value table. And so you have the user ID of Kenny, you have the attribute ID that's related to email, and then you have a value column. And so that's Kenny AOL. And then you can do the same with phone number. You can do the same with the Twitter handles and whatnot. Jenny only had 2 points of contact, so she would only have 2 records in this attribute value table. And so this gets around the problem of having gaps in the data. There are no longer gaps in the data. One of the problems is that you can start to have complex queries where you now need to join stuff where you maybe shouldn't necessarily have to join tables together to retrieve information. And we see the queries that we would actually run to retrieve. Anybody that has a LinkedIn contact would be returned here. If we wanted user IDs, contact information, we would run this second query. But a big problem with the entity attribute value, and let me know if I'm missing any, I think it's the value column itself. Because the value column can take any type of value, be it integer or decimal or varchar or text, the data type for the value column has to be something that's essentially amorphous, so text or blob or varchar 256 or whatever. And one of the big benefits of relational databases are the different data types that you get. You can have integers or small ints or blobs or varchars, and you can have one for each column, and it helps with your storage. It also helps with the optimizers for the database engines to better help you when you go to actually access the data. It helps the optimizer know, okay, columns values in this column are integers, or values in this column are decimals, or values in this column are cars or characters. Whereas with this value, you lose all that information. And so again, I haven't implemented this, but this seems to be maybe the number one issue with the entity attribute design. Also, it's great that if you want to add attributes, you can just add records to this attribute table, but you can really start to complicate your queries and just kind of muddy up your database design using this pattern. I don't know if there are other issues with this.
The thing about keeping different data types in one column is true, but I think the most common use case for this is like configuration values, for example, where you they're all strings anyway.
Okay, okay.
But to me, the problems I've had with them have more to do with putting queries together.
Okay.
You just need to query one thing, or one set of things is 5ES. As soon as you want like multi-column results and joins and stuff, it gets crazy.
Gets
You
nasty.
basically built a database on top of a database at that point.
That's awesome.
Suffers as you think of it.
Right.
Yeah, performance, and even in configuration values, you're gonna have booleans. So now you're talking about strings versus booleans. So,
Yeah, you don't ever want to have to do like a where clause on the value.
yeah, that's the problem.
Yeah.
Or you don't ever want to sort it by the value column, because your base data type, which is probably going to be a varchar, most likely, it's what the most common choice is my understanding, is going to sort by alphabet. And it's going to get to 100, or like 110 and 11, it'll sort them right next to each other because they're both 1, 1.
Right.
It starts from the left and goes right, instead of actually knowing that it's 11 versus 110. So,
So yeah, like I said, some people call it a pattern, some people call it an anti-pattern. But we don't have to worry about it because we have JSON to the rescue. So up top is what we just saw, that's the same, but down low we've changed. Instead of using the EAV pattern, we're gonna just use a JSON data type. And so one table, user ID, username, and then we're gonna create a new column called contacts. Data type is JSON-B, and we're just gonna throw everything in there. And so, like I said, the queries up top are what we just saw in the previous slide. The queries down low are what we would use to get the similar information out of our new JSON-B table. And you see the queries look a lot cleaner, and they won't, you can continue to throw different stuff inside this context column, and the query won't necessarily change and get more complex. And to Matt's point again, you're throwing a bunch of stuff in your junk drawer, so that could be good or bad depending on how you use it. Let's see. So some semi-practical examples of JSON use cases with relational. Okay, here we just wanted to show, we see the shopping cart, everybody's familiar with it, especially since we just came out of the Christmas season. The thought here is okay, well, how would you model a shopping cart using JSON as the data storage, or at least, if not wholly, partially? We can, this is just a screenshot I grabbed from Google. We can associate a user ID with this shopping cart. We have a date associated with it. We have our subtotal of 134.96. That could be a top level JSON element. The real power is this products array. And this is just me just kind of speculating how we could, in theory, model this shopping cart. If something looks wonky, definitely I'm all ears. But yeah, the products array, we've got a complex array. We got complex elements inside this array that correspond to each item in the shopping cart. And even though the elements in each array are all identical, that there's nothing that says they have to be, and that's showing the power of JSON. So we want to add another item, that would just be another record in this array, and that seems to be a pretty natural fit shopping cart for storing your data in a JSON format. Again, even if you didn't do it wholly, if this was maybe a regular field as the user ID, the date, and the subtotal, your products, you can have that just be stored as a products column with the JSON data type, and that seems like that could work pretty well. Another use case is front-end preferences.
oh yeah, So literally, I'm using this today and an application that I built out. So the industry I work in, there's a lot of hardware that we maintain information on, analytical data, millisecond level data on levels across hundreds of assets. Essentially, the API guys were really worried about that side of things, and they didn't really want to worry about the UI. I said, well, give me a JSON column type that I can just store my stuff in, because you don't care about it. I want to manage it. So what I did was had them add that JSON column type. I manage all my preferences. I query that column. I had them write a route that just returns that data. And whenever I need my data, I go query that one route that only returns that data, and I have at it. They wrote another route that stores my data. So with 2 routes and 1 column for them, I was able to get them essentially out of my way, and they could go on doing what they were worried about. They don't care about my preferences, whether or not this portion of the screen is minimized or whether or not you have permission to that part of the screen or whatever. They don't honestly care about it, but I care about it, and I need a way to persist. So that's the one use case that I'm currently doing right now.
Do they name that column like Matt's junk drawer or something?
It's something along the lines of UI preferences or something like that. This particular one is with the user table. Although, no, I will say we have companies as well. So I actually have multiple tables that have multiple preference columns in it. I have each level of entity that is related to a given person. So company, site, location, or whatever, and user. They all might store varying different preferences. So like the company level preference, it would apply to the whole, anybody that belonged to that company, and then so on and so forth. So there's a couple of tables I had. Again, you have to come back to the traditional database design. You're still in a relational database, so you sort of kind of got to put it in that database in an appropriate place. Or you just create a table that has 1 column in it.
There you go.
You know, I wouldn't recommend that, but that is a workaround. So.
Well, I mean, I think when Postgres came out with JSON-B, people were saying that spelled the death knell for MongoDB, because they're like, well, why wouldn't people just have a single table or a table with just a column JSON-B? That's Mongo, but that's not really correct. But
There are performance issues, I think, still.
yeah, sure. Let's see, I think this is you again.
Oh, I actually have a friend who works down at BJC, and his whole job was to take a medical information system from another hospital, suck it in, transform it, push it back out. So they just needed a place to store whatever came into their through their other API call that called out to the other medical system. So literally, they created a JSON column that had an index on it that they could make sure they didn't get duplicates and all that stuff, primary key, and they just stored whatever they got back from that into this database table, into this column, so that they could then come back later, and they essentially used it like a JSON queue. So, but then they could associate, you'll see later on why this might be desirable over using a document store, because you could sort of drill down into it and get some indexing and some other stuff going on, and later on in the talk.
Yeah, so Trello, we talked about Trello. You have Trello cards, which are your task level items, I guess. And here's an example of a Trello card. And again, it seems like JSON is a natural fit to store card level data from Trello. Won't go through all these all these elements. I just want to point out the different arrays that we have. The members array, which correspond to these 3 happy looking people. That's a pretty natural JSON feature. The labels, same deal, marketing, design, web. We have this sections array that I created, and I think that could correspond to this website redesign asset section. And within that array, we have another array for the different images for a given section, and there's only one section in this example, but, if there was another, I think we would probably just wedge another array right here in this sections array, and we're off and running. So, and then we have this checklist. We've got items that correspond to the items here. We could add a completion indicator of 1 means it's X'd out, or of 0 means it's still live. And so it seems like a Trello card is another semi-practical use case for JSON as a storage format or structure. So Slack, hopefully everybody's on Slack. Hopefully everybody's on STL Slack. So Slack reactions, everybody's probably giving a thumbs up or a smiley face in Slack. And so this is just a screenshot of our channel. And I just want to really focus on these 2 reactions here. This first JSON format is related to this text. And we've got message ID and user ID and all that stuff, but again, we've got a reactions array. And so we've got the icon for thumbs up or +1 or whatever. We've got a count value of 2, and then we've got the user IDs of the users that actually gave the thumbs up. That seems like you could model something like that pretty naturally in JSON. If we look at the message of the JSON object below, it's for this same deal, but the reaction is now the laughing icon. There's only a count of 1 and a different user ID. And I just wanted to point out, I think, this is again me speculating, but you have to model something like this, even if you do it in a purely relational way. The user ID of 31, that corresponds to me in this example, and that's how I'm able to get the light blue treatment from Slack, letting me know that I was actually one of the people that gave the thumbs up, whereas down here I didn't, and so I could go and press it and get the light blue treatment. But yeah, I think you could realistically think about using JSON to model Slack messages like this. I'm not saying that that's how they do it or it's how you would ultimately do it, but it makes sense. Here's an example where it probably doesn't make sense though. So same example, but now you think, well, Slack, everybody should be happy and nice on Slack, but sometimes people run amok, and so you need admins, right? So you have people with admin privileges at this STL Tech team level. We also have people with admin privileges at this STL Full Stack Web Dev channel level. But you could, in theory, say, no, we want to actually manage admins at the message level. And again, I'm not saying this is a good idea, but you could model that. You'd have an admins array, and you stick your different user IDs. And if somebody wanted to wipe out a message that wasn't necessarily theirs, but they actually had admin privileges, you wouldn't have to join other admin tables to do it. You could just look at this one table, look at this one message, and just say, hey, your user ID that ostensibly is in your cookie, is it in this array? And if it is, you can take whatever action you want to take. If not, you can't. And again, that helps you avoid joins, right? The problem with that, though, is if you make any changes to the admins, if you add an admin, you have to go through all of these messages and add that admin's user ID. Or if you lose an admin, you have to go through all the messages and remove the admin ID. And obviously, that's problematic, and you don't want to do it. So just showing that, even though you can do something with JSON as far as data modeling, you may not want to. And I think a lot of it probably comes down to updating, just, the example before where it was reactions. If I decide to like renege and take my thumbs up away, then I don't have to mess with any other messages. I'm fine. And so that makes a little more sense. Here, though, yeah, if you make a change to one of these, you're going to have to make a change to all of them, and that's problematic. And so just trying to show a bad use case for JSON, not trying to completely drink the Kool-Aid here. So downsides, we've covered some of these already. You're going to store extra bytes in your JSON just with your key names, if nothing else. And so you do have to worry about extra storage. Now, sometimes you will actually gain on a net basis, like with the entity attribute value. Those where you're able to avoid with the extra foreign keys from the EAVs may offset the extra bytes that you have in your JSON data type. So you may actually win on the storage front, but it's worth just noting that storage may be more of an issue with JSON, especially JSON-B and Postgres. Lack of statistics. Again, the data types help the optimizer, or help the database engine feed the optimizer. And you know, if you have more up-to-date, accurate statistics about your data, that helps with your querying. And so you lose a lot of that data type information when you use JSON because it's a junk drawer now. And so that's another downside of using JSON. Heavy updates and inserts, you know, even though you can index JSON data types in some of these databases, you know, if you really got a heavy update and insert type of application, you know, as of right now in 2019, you know, JSON-B may not be the best data type for you, so you want to watch out for that.
The indexes don't help with the heavy updates or inserts.
Oh, God, Jesus Christ, yeah, no.
No, I'm
Yeah,
just saying.
you're totally right. Yeah, my bad. I'm sorry. Yeah, it actually would hurt. Yeah. So, but I think I still have read that with heavy updates and inserts. We'll talk about the different JSON types in Postgres. Even at that, though, JSON still may not be a great data type
No,
for you.
I'm saying that the indexes hurt you even worse.
Yeah, the indexes do, but even with JSON where you don't have indexes and it's just JSON, it still isn't necessarily great. Yeah, sorry about that, guys. And then Matt mentioned this earlier, and I've kind of alluded to it. Lazy database design, it can become just a junk drawer, and you can just start throwing stuff into your JSON fields. Yeah, if you want to properly design a third normal database in a relational world, yeah, that could be kind of a pain, but it does force you to think about your data structure and your application, the needs, and it's just a good exercise. Even if you ultimately don't use your database design, it just is good for the thinking. Whereas, you know, if you use JSON as too big of a crutch, you can really get sloppy with the way you think about your database design, and that's never a good thing.
It's kind of, I mean, I don't know specifically if Postgres provides tools for this, because I haven't worked with this specifically, but like once you start using like a NoSQL type database, you're really locked into how data was saved. I mean, you can, oh, I have a new record, I'm going to save it, I'm going to have a different structure, that's fine, but you can't say all the, I don't think it's really possible to say all this stuff that's been saved so far, like change this column to that column, or this property to that property.
Well, what you can do is you can duplicate the data and in a different row. You can just, because that, you know, that it doesn't matter, it's big enough that they can handle it. And then it's just the same data but in a different way in the row as well.
And with some of the tools we're going to show you on how to manage JSON sub-entities, I'll go nodes or however you want to express subcomponents of a JSON document. It is possible. You know, I could build a mountain with marbles too, but that ain't exactly a practical thing to do.
Right. Like in SQL Server, you say, you know, alter table, whatever, and then go
Right.
column.
Alter this column to rename it, essentially. Yeah, that becomes very troublesome in a JSON data structure.
But I guess in your example, where you say you duplicate the data, so you would have two sources of truth, or are you saying, are you versioning essentially? Okay, all right.
Well, if you have the data in two different ways in the same table, and that's the access, this is for like, SQL, right?
Oh, okay.
And so you'll access it, you know, based on your access pattern 1 or access pattern 2, but you duplicated the data.
Gotcha. And actually, Cassandra, is anybody here familiar with Cassandra or work with Cassandra? They actually say that's the way you should design Cassandra tables is don't try to have a single source of truth and access it different ways by hitting the same source. They say, no, duplicate the data and morph it, hard code your data access paths, and just do it a bunch of times. And you know, so you worry about, well, wow, a lot of this data is being duplicated. What about inconsistencies? But Cassandra was built from the ground up to address that. So I'm sure it's not perfect, but that's kind of the dice that they're rolling.
The whole idea is like if you're trading off storage space for like CPU, like operational efficiency, you know. So yeah, we're gonna have all this crazy duplicate data that's gonna be stored way less, you know, it's in a denormalized fashion, but you know, storage is
Sure.
cheaper than
CPUs.
churn through the joins and all that stuff. So,
Not-
you know,
Right. I guess you also have to start worrying about CAP as well. You know, I know a lot of these NoSQL databases. So CAP, the CAP theorem, if anybody's not familiar, is you think of a triangle. You have consistency as your C, availability is your A, and P is partition tolerance. And you can choose, if you have a database, you can choose 2 of the 3. So if you want consistency, that means, okay, if I am querying this data, I can be pretty sure that this is the right value, the most up-to-date value. Availability means, okay, you know, if there's some kind of issue to the database system, I won't necessarily lose everything. I'm going to be more available. And partition tolerance is I can actually take my data and split it onto different machines or whatever. And so with relational databases, they, I guess, essentially chose the C and the A. There is no, by default, traditionally, there isn't partition tolerance for relational databases. So single server is very consistent, it's going to be available, but when you start using some of these NoSQL solutions like a Cassandra, where you start breaking your data up, you kind of pick the P, and so then it's like, okay, well, you can use the C or the A now. So do you want your data to be consistent and always kind of in sync, or do you want it to be more focused on availability and you know, where maybe, you know, think about, you know, they talk about cat photos or whatever, or Facebook posts. Maybe when you go to Facebook, you're not necessarily getting the most consistent, up-to-date data, but who gives a shit, right? But it's going to always be available to you. And so, yeah, I'm sorry, I'm just kind of riffing, but yeah, there's trade-offs in all this stuff. And yeah, even though you're starting to see some vendors try to promote themselves as the silver bullet that kind of, you know, serve all these use cases, that's just not the case, so.
And to your point, I don't think any relational database has implemented the versioning yet. So that is a very good point, that if you're going to need that, or morphing in any way, shape, or form, I mean, you're going to fall back to your traditional document style database.
Yeah. Right.
We're back to traditional now. It's been around long enough that it's actually standard. So.
Yeah, for sure.
So is it easier to query the data with the JSON type of JSON, or is JSON B? Like JSON B is easier.
We're going to talk about data
Yeah.
types because they're different based on the system you pick. To answer your question, is it easier to query?
Like if I want to drill down into the JSON and
We're going to cover it.
some bad things.
Yeah.
We're going to cover it.
So we're getting close, actually. So yeah, some of these implementations of JSON and these traditional relational databases. So yeah, I kind of talked about this Postgres, the feature rollout. It probably leads the majors as far as its JSON functionality. So with version 9.2 of Postgres, which I don't know, maybe 5 years ago, 6 years ago, they had the first JSON data type, and you couldn't really do any of the drilling that you were talking about with 9.2. It was just, hey, we will allow you to store JSON into this column, and if it's invalid JSON, the database will choke and let you know. So like your API example, you can just kind of store the API responses here. If you wanted to drill in there, you could process it, but it was almost like, it was essentially text processing and all the, you know, fun with that. So 9.3, you start to see actual extract operators on that. But 9.4 was the big one where it's like, okay, now we have binary JSON or better JSON. And so now we can index the actual nested elements in here and actually drill down and maybe get better performance when we're trying to read from within a JSON.
And to clarify, this was a glorified text.
Oh, it totally was.
Right here.
Yeah.
This became a
Yeah.
binary format.
Absolutely. The cool thing with the 9.2 though is that it understood JSON and valid JSON syntax.
Right.
So,
I only pointed out because it's going to matter in the next couple of slides.
yeah, true that. Yeah, and then JSON-B modifiers, JSON-B insert, more fine-grained insertion capabilities, full text searching for JSON-B in version 10. Version 11 of Postgres came out last year. I don't really know exactly what the new JSON features, if there are any world changers in there. Is anybody familiar with Postgres and JSON? Okay. So, but yeah, I'm sure 11 had, at the very least, it probably improved the performance of JSON and all that good stuff. And again, all this shit is converging. So Postgres, so we have two different types of JSON. We have regular JSON and then we have the binary JSON. And here I'm just showing kind of the talking points for the two. Just going down the JSON list, well, yeah, JSON preserves your white space. So if preserving the white space and that JSON value that you store in the database, if that's important, you're going to want to use JSON. Preserving the key order and duplicate keys, yeah.
Preserving white space includes carriage returns.
Oh, there you go. Yeah.
So if you want it to be, if it comes in pretty formatted, you want to keep it pretty formatted, that's one of the things. Otherwise, you're going to have to reformat it when you pull it out, make it look pretty again.
Absolutely. Yeah, so duplicate keys, preserving the key order, that's all kind of part of that. Heavy writes, again, put heavy in air quotes. You don't want a super write intensive application to use JSON, but relative to JSON-B, JSON's probably better for writes. And then you have some examples, log files, API responses, maybe Slack messages. I don't know, because it seems like the formatting is kept there. But anyways, so some examples there. And then JSON-B, that's the binary. So it's more space efficient as far as removing the white space between the keys. Key order doesn't matter. It won't allow duplicate keys. It'll take the most recent key if there are duplicate keys, and it'll only store that key in this value. Better for reads because you're able to actually index the elements, the column itself and the elements inside the column, which is nice. And it's, according to Postgres, unless you have one of those niche needs like the API example, or if you need to maintain formatting, use JSON-B at this point. It's just better performance.
So MySQL came out with their support well after Postgres. Is version 9 started, and I may be getting Postgres messed up in here too. So I apologize. I'm sorry. 5.7. There we go. Is when they started supporting it. But so they jumped they don't have a text version of JSON. If you want to store JSON and keep all the formatting and stuff, you just use long text or whatever you need to use as a normal text, and then you manually deal with it just like you would have normally. So they're removing white space. They have arbitrary key order. They don't do duplicates. They allow indexing via virtual columns, but they do have an awesome 1 gig per field limitation. Now, 500 meg coming back, or 5 meg coming back was ostentatious. I can't imagine trying to query a gig per field. So,
Even as a separate database in each of those field
Right.
and then MariaDB. So, everybody familiar with MariaDB versus MySQL, right? The evil Oracle now owns MySQL. The day that Oracle bought MySQL Foundation or whatever organization it was under and took control of MySQL, the valiant open source developer community grabbed the last open source version, renamed it to MariaDB, and headed off in their own direction.
No. That was the creators of MySQL.
Well, but they kept it as
it's open source.
open source, but it's now 2 different groups.
Yep.
So at least in charge. So they went off trotting on their own. When it came to JSON, they made some very interesting choices. They do not have a JSON data type. They do have a JSON data type alias for JSON. So when you can do for MySQL compatibility, you can create a JSON data type, but when you look at the underlying data structure, it's nothing more than a long text. Okay, it's just an alias for a text column. So you end up with what you had in JSON or Postgres JSON. You get all the snazzy stuff, and they allow you to store up to 4 gig. But they don't do JSON data type checking by default, and might be incorrect about that. I'll have to verify that one. But So as far as similarities go, if JSON is important to you, I would suggest going MySQL if you have that choice. Some people prefer not to get in bed with Oracle.
Not Tesla.
I threw these, you'll see this throughout the presentation, just for those people who just feel the real need to work with a file-based database. SQLite actually has an extension for JSON data types. It gives you, it's a text, it preserves, it gives you all the stuff that you would normally get with a text column for JSON. It has no enforced limit. You can consume the entire file size of a SQLite database with JSON data. And then there is no validation on it, so you have to run a validation on the actual JSON string as you're inserting it or modifying it or updating it into that field. So you have to wrap each string in a function call. Not super hard, but it is something you have to keep in mind if you're going to use SQLite. And we aren't using JSON, but we use SQLite on a lot because we do mobile devices. Well, I shall say, not mobile devices. We use hardware devices that are stationary in a given place that run on an ARM device that are not connected to the internet and don't have the resources to run a relational database. So we use MySQL a lot, or SQLite a lot. So it's still used in production quite a bit.
SQLite is the most widely used database in the history of humankind. It's amazing.
Yep. If you want a proof of concept something, look into this because it's super easy to get stood up.
All right, so yeah, we've got some basic syntax just to cover. Add in a JSON compatible column, see it for the different vendors. Roughly the same. Maria's a little different with the JSON check, I guess. You got anything you want to add to that?
No. So the JSON check on MariaDB, it allows you to use the check syntax and then apply that JSON validator to the actual column, so you don't have to do it in every SQL statement you make. So you're literally applying it to the column type as opposed to each individual insert you would have. So like on SQLite, you would wrap this around your insert statement for that column. But MariaDB allows you to just add it, do this function, run this function every time this column changes. So
now that you have a snazzy JSON column, you can start putting data into it. So up top, we see the three major vendors, and just insert statements are pretty basic. Everybody's done an insert statement. Just highlighting the difference between Kenny's insert and Sam's insert. You know, that's again the beauty of the JSON data type. They don't have to have the same data structure, which is pretty liberating, assuming you don't get too goofy with it. And then we see SQLite.
and there's the JSON function wrapped around the JSON that I said was required to make sure it's valid.
Right on, okay. And then I just want to highlight Postgres. In 9.6, Postgres came out with this JSON-B insert, which allows more fine-grained insertion of capabilities. So, you know, you can run it kind of like an update. You pick your column that you want to actually insert your new values into. We're going to insert a new Kia phone and then this value in here for Kenny, and it'll just kind of plop in here essentially. So I'm not sure if MySQL Maria have anything quite like that yet, but
If it does, I don't know about it off the top of my head.
that's cool.
It may very well.
Select statements, pretty well. So we have these arrow accessors. So a single arrow accessor in Postgres world, I'm assuming it kind of works the same down here for MySQL, will return a JSON element as an object, which sometimes can, you know, that's exactly what you want. If you use the double arrow accessors, it will return said JSON element as text. And then here I just wanted to show that, you know, we can use this in the select statement, but we can also use this arrow accessor in our where clause as well, which is a good place where you want to put it.
I think the operators in MySQL actually reverse.
Are they really?
Yes.
Okay, so
if
this,
you use a single arrow, you get back a string.
okay,
If you use a double arrow, you get back the value pulled out of the string.
interesting, okay.
And your question, ma'am, here's your pathing to start querying subsections of the column. So you could do that. We're doing that here and here, but we're also representing it in the where clause. So if you wanted to get all the Twitters, you could start nesting it like that.
But that's only valid in JSON B, not in
So JSON-B is unique to
Postgres.
Postgres and MySQL and MariaDB, which actually has the same. No, it does not. They essentially JSON data type in MySQL is JSON-B. They never implemented
JSON.
standard JSON because they were just behind the game of Postgres and they didn't feel it was worth it. Plus, it's nothing more than an alias for a text column, so call it what it is. So, and JSON functions do work on a text column, they're just not as efficient, is my understanding. And then down here on MariaDB, you actually have to call out the fact that you're going to query for the value of the contacts directory, and you want to use this path. And both MySQL, SQLite, MariaDB all use. This is the same notation that most JavaScript uses to access a JSON object, so they just follow suit with that.
Well,
Whereas $sign represents the root of the document.
updates are pretty, well, they're not super straightforward, but we have this JSON-B set function. Again, you specify the column, you specify the elements in the column, and then the value that you want to actually, the new value. And it looks like that's pretty similar for the other vendors with the exception of this dollar dot.
Yeah.
Deleting, there are multiple ways to delete, but here's a pretty straightforward one. Again, kind of going through the update and then just selecting a column, and then you can just use minus, and then if this is a top level element, you can do something like this and it'll remove the key and the value for poor Kenny. And yeah, I guess you have a JSON remove function.
So yeah, Postgres has went more to symbolic Boolean operators, a lot more. I think the other vendors have pretty much stayed with the function call kind
Gotcha.
of mentality.
Which I personally, aesthetically, I prefer this, I think. Especially we'll see some of these operators that Postgres provide are a little funky looking, whereas this just seems really more intuitive. And then indexing. So I don't have a lot on indexing for this presentation. If we do a follow-up, indexing is definitely going to be something that we want to kind of get more into. But you know, creating an index, you can create the index on the entire JSON column in Postgres, or you can create the index on the specific elements within the column, which would help if you're trying to traverse and extract nested elements inside your JSON. And it looks like it works about the same for MySQL and Maria.
Well, in Postgres, you get to do this in one fell swoop. Inside MySQL and MariaDB, there's a concept of what's called a virtual column, and there's also a stored column, which we'll talk about in a little bit. What you do is you essentially add a new row to the table, and you calculate that row's value is going to be provided by, well, here's the stored, provided by this path in the JSON column, okay? This top one will dynamically calculate that every time the database is queried or that column is queried. The stored version actually cherry picks the value and plunks it in that virtual column, stores it perpetually until there's an update made to the JSON, then it updates it. So in theory, the stored version would be more performant because it doesn't have to calculate that every time the table is queried. So, and then to create the index, you would then now create the index, a standard traditional index on that virtual column. So the magic in this place is the fact that they have virtual columns. And then MariaDB essentially does pretty much the same thing. Their syntax is a little bit different, thus the different line.
Let's see. Oh, I guess, yeah. So we have some code examples that'll maybe illustrate some of the nuances of the syntax. Okay. Let's see here. All right, so what I have here, I guess we're on a Linode instance, and I have a users table. We've got our 4 users in here, and you see we've got context column, JSON B is the data type, and we've got just some contact information. And so I'm going to run some queries on this, and we'll see how to access it in different ways. Let's see. Oh, there we go. All right. So we have the concept of existence and containment in Postgres. And so containment, you have this ampersand or whatever arrow. And so essentially we're saying, okay, does this value on the right actually, or does this value on the left contain this value on the right? Does context contain the key of email with the value of Kenny@AOL.com? And so it's not in my where clause, but it's in my select statement. And so here we see we get a true for Kenny, and then we get F's for false for the others. And so we can also put that into our where clause. Oh, man.
Bear with him, he's using my computer.
Yeah. And so, yeah, so we would only return the Kenny record there.
And in MySQL, you would have to use the JSON contains method or function to get the same result.
The true, is that a column or
Which,
I'm sorry, what's your
What's-
question?
clause, is it like a column that exists or is it something that's computed?
no, well, okay, so this is our database table right here. We've got ID, we've got username, and we've got a context column, and the context is JSON. And so now we're just going to access elements inside this.
I don't see T, I see true in there. So
Oh, yeah, that's computed. That's just saying, yeah, that's all. And I just wanted to show that in the select statement to show that's what it's showing. It's saying, okay, well, Kenny is the only record that satisfied this condition, so it's going to come up as true. The others will come up as false. If we were to put that same condition into the where clause, we would only return the Kenny record, which is probably more what you would see in real life. And I think these containment and existence, or this containment operator, I think was not there in the beginning for Postgres. I think they recommend this is how you should actually try to access data, containment or existence wherever possible. You can also say, okay, well, existence, does the string exist as like a top level key? And so we can select, we're essentially just saying, okay, man, where's your insert key on the laptop?
It's on the number pad, but you got to turn off the number pad.
You have to turn off the number pad?
Yeah.
That's not what I'm-
It's you'd have to hold function and then hit delete.
Okay. There we go. Okay. So yeah, so here when we ran this saying, okay, grab me from users where any of the contacts have email, we returned only Kenny, Sam, and Pam because Jenny didn't have an email. So again, that's using this question mark for your existence. We can also do something like this.
You can right click and I think it'll, no?
No, didn't do it.
Control V.
There we go.
No. Yeah, the only operators that MySQL and MariaDB support is the arrow and the double arrow. At that point, they diverge and go to use Maria and MySQL go to using actual functions, declarations. Behind the scenes, that's all it's doing is wrapping the thing
Yeah.
behind it in a function and executing it. But yeah, the syntax does not transpose to MySQL or Maria.
So here, yeah, we're going to run something similar. We're saying contacts. We're going to use that arrow accessor. We're going to look for a last contact element, and we're going to look for a top level within last contact of reached. And so you see here for Jenny, we have last contact, and there's a date of the last contact, and there's a reached element of true. And then the same deal for Pam, but her reached is false. And so this should just pull those two records back, and it does. So here's an example of where we're actually now starting to reach into the JSON element and reach into some of the nested elements to actually retrieve the appropriate records.
Where is contact defined?
No, you're fine. Where's contact?
Where is contact defined?
I just created this
No.
table.
Contacts is the name of the column.
It's the name of the column. Oh, I'm sorry, yeah.
Yeah.
Yeah, so we have ID, username, and contact.
It's identifying the column you want to query, then it's finding last contact inside of it.
And
Then it's
we'll erase.
determining if that has reached inside of it.
Yep, sorry about that. Thank you. Let's see, so a cool thing you can do with Postgres, you can look for top level keys within an array, so you can feed an array. So we're saying, okay, go to the contacts column, look for last contact, and then look for, does the last contact contain either a date top level or the ZZZ top level element? And they both do. They don't contain the ZZZ, but they both contain the date. You can also do it to where you say, hey, same exact thing, but now I actually want, you need to have all of these values as top level elements. So again, go to contacts, go to last contact, and then look for these elements. Is there a date element? Yes. Is there a ZZZ element? Well, no. And so because of that, we don't return any records. And it, depending on your use case, that may be exactly what you want. Nothing really comes to mind right now, but maybe something with preferences or something like that. But yeah, that seems to be pretty helpful.
And go back to the
Which one?
terminal.
Yeah.
So the nuance here is this has got a question mark.
Oh,
and,
God, yeah.
which is your traditional AND operator, and this has got a pipe, which is your traditional
Right.
OR
Yep.
operator.
Thank you.
Just wanted to point it out.
Yeah. Yeah, for sure. Yeah, and just showing an example of where it will work. So yeah, date and reached, and both of those satisfy that query because both of these last contact elements have these top level elements in there. Let's see. So deleting, we already saw an example of deleting, but now we'll see it in action, I guess. So here we're going to contacts, we're just going to We're actually not going to delete this from the table. We're just going to return the select statement. We return the username, and we're going to return the contacts column minus the last contact from users. And so we see here, I think Jenny and, I can't remember who had the last, I think Jenny and Pam had the last contact. You see they're gone now.
But I'm sorry,
No,
because
go
that was in the select side of things, it wasn't in an update statement?
Yeah.
That was a non-destructive removal of the data.
Absolutely. We can also remove multiple elements at the same time. But doing something like this now, here we can't just use the minus, we have to use this pound minus operator that Postgres provides. And here we're going to drill into last contact and remove reached. And then we can also do that, drill into last contact and remove date. And obviously we didn't have to do both, but this will allow us to remove both at the same time. And again, not permanently remove, but you see now we have a gutted out last contact object for both of those records.
So the difference there was the whole, and the value you were removing the first one, was just the value of the second one, or I missed the difference?
Well, the first one, the entire, everything, the object itself was just stripped out. And so, if that's what you want, that's fine. But if you want to be a little more fine-grained with it, you can use the pound minus, and you can maybe be more surgical with what you remove. And then even if you remove everything from there, that object will still remain. So maybe that's what you want, maybe that's not. But you can only get that with the pound minus sign. Yeah, and at some point, MySQL and Maria are going to have this stuff, right?
I think they have it all except for it's in function calls instead of.
Oh, this is still, okay, that's cool.
I believe that most of the functionality that he's showing using his operator syntax is available in MySQL. If you go to the resource slide that at the end of the presentation, there's a slide for MySQL and MariaDB JSON functions, and it's a whole nother talk in its own right.
Yeah.
If not two, if you really wanted to delve deep into what you can actually do with JSON functions inside of MySQL and MariaDB. And for that matter, SQLite has a pretty good chunk of them implemented as well.
So here we're going to try to remove, well, let me see, let's do this. Just a minute, 1 second. What's going on? Oh, got it. So I'm going to pull up the data again. Damn. Let's start. Anyways, all right, so this is our data. Here we're going to try to remove the notes element and the email element from users, and it's going to kind of crap out on us. And the reason is that this pound minus is actually looking for a notes element and then a email element within notes, and that's not what we have. We have a separate notes element and a separate email element that we're trying to remove at the same time. And so if we want to do something like that using the pound, if we want to do something like that, we want to use this type of syntax here, where we just use the minus and we put notes and email still in the same object, but then we're going to actually convert that to a text array. And so with Postgres, and again, we're not permanently going to remove this, but now it'll actually say, okay, now I know that notes, email has now been cast, and that's what's happening here, cast into a text array. And so now I know, okay, let me use this regular minus operator to actually go through the array and just look for a notes element and look for an email element and remove that. And you see there are no longer any notes or email with that. And I guess, this code will be available and it's in the documentation, all that. The point I really want to stress is just the kind of the wonkiness of the syntax that Postgres gives you. It is powerful what you can do with this stuff, but looking at pound minus and question mark ampersands and question mark pipes and stuff like that is kind of disconcerting sometimes. And I actually struggle with trying to get this together But yeah, once you kind of get it, there, like I said, there's a lot of power to this. Let's see here. Where's the last contact reach?
Ryan, quick question on the index part.
What's up?
When you create that virtual column, do you query against the virtual column, or do you query just like you would against the JSON to use the index? Maybe I wasn't asking right. So I saw you create a virtual column, right, that either computes or stores, and then you create the index against that virtual column. If you query against the JSON data, does it know to use that index, or do you have to actually query against that virtual column to use the index?
It's a good question. I'm not quite sure. But you do get the advantage of that virtual column. So if you want to just query on that column, you're going to get back so you would query on the virtual column and then your JSON column. And you would get back the values that match what you were looking for in an indexed fashion.
So does the virtual column actually store data, or is it like a?
No, well, it does two different ways. It does one is the virtual column by itself is calculated.
Okay.
If you do a stored column, it's
That's-
actually a virtual column that temporarily, well, it doesn't, it perpetuates the value that's currently in the JSON to where you don't have to
I only asked because
dynamically calculate the value that's in there.
for a second it sounded like this could be treated as like a covered index maybe, or something like that, where you have your index with just the field, like in a relational database. Yeah, and if you can just hit the covered index for all the fields there, you would never have to go to the actual underlying data. But I'm not sure if that's what's happening.
If you wanted to take the time to create virtual columns for all your JSON attributes, you could get it.
Yeah. Gotcha.
And you don't have to index all of those columns either. It's because that is a separate step. So if you need to extract something maybe that's 10 layers deep to get that value up on top, could be even another JSON object, right? You could just be extracting out a subset of data into another column, and then you could use that data structure. You could simplify your data structure that way. So you don't necessarily have to index that virtual column after you create it. So,
All right.
you follow what I'm saying? Okay.
Let's see here. So here we're going to actually, again, not permanently delete, but just drill into the last contact, and we're going to remove just the reached element, not the date element. And you see here, just the way I have it set up, we're just returning the contacts, and you see, the dates are still intact. And so, that's a way you can be more precise with what you want to extract out from these JSON elements. We're going to run the exact same thing, though. Instead of the single arrow operator, we're going to use the double arrow. So before we did the single, and it returned that last contact as an object, here it's going to return it as text, and it's going to crap out on us. And the problem is that when you do this, it's going to bring back whatever values as a text field. But what we really want to do is we want to bring that as an object and traverse it to get to the reached nested element, and we can't do that with text. So just showing because as I'm learning about this stuff, I'm just wondering, it's like, well, why would I ever want to use the single or use the double arrows? And here's a case where you have to use the single arrow as opposed to the double arrow, which then begs the question, well, why would I ever want to use the double arrow to just bring back text? Why wouldn't I always want to retrieve stuff as objects? And I'm going to assume, I don't have an answer, I'm going to assume it's maybe a performance issue. I'm thinking maybe this returns stuff a little bit faster if it's just a text representation, but.
It also may be an expected response. It may not be expecting a JSON object, so you want to return it as a string so that
Oh, I got you.
it can handle the string that it gets back.
Okay.
Or if it's an integer value in the JSON, and you got to convert it back to a string so that it can be handled correctly.
Very possible.
JSON doesn't really, or JavaScript doesn't really help typically, but not everybody's using JavaScript. So,
Sure.
and in case in point, TypeScript is typed, it's going to expect something of a given data.
Oh,
type
really?
back.
Okay. All right.
So,
Yeah, I'm not a front-end guy. So. Anybody have any questions thus far? Okay. Let's see. So yeah, the last set of queries, I wanted to add a new column. Let's see, I guess a preferences column, just to show some JSON insertion and updates. So we're going to add that to our table. So now we got a nifty. Let's see. So yeah, we've got our contacts and we've got our preferences now, and we'll start including some new data.
Triple click or double. No, triple.
Okay.
Yeah.
Yeah,
There we go.
All right. Yeah. Learning. All right. So we included a set of preferences for, I'm thinking like the UI, the background, you want sky blue. We got an empty categories array. We've got a miscellaneous object only for our Kenny user, which is all we're going to really focus on. And here we're going to, let's see, username. So you see here we've got our new data that we just inserted. And so here we're going to update this and add audio preference with the value of 1. So maybe, keeping our audio enabled, so when you go to the website, the preference is, okay, you want to hear beautiful music or whatever the website's playing. So we're going to do that. Problem with that is that we just essentially wiped out all of our preferences, which is not what we wanted to do. We wanted to add the audio to the existing JSON element. And so what we can do is instead is we can use a more fine-grained way of inserting data. So here we are going to use the JSON-B insert function. We're going to specify our preferences column, and then we're going to specify our new key that we want to add and the relevant value. And that should do the trick for us.
Oh,
How do I
you're adding audio after you already added it once.
Oh, I got a crush. Yeah, there we go.
Yeah, so you want to run that one.
Yep. So, yep, there we go. Good call. So then now this is kind of closer to what we wanted to do. So again, this was not available until 9.6, I think, so within the last couple of years, but that's pretty powerful. See, we can also add some additional fields as well. So now we've added just some miscellaneous stuff, an option A and a yin value and an option B and a yang value. Just don't really mean anything. Let's see, we already tried to do that. So we saw, I'm not going to run this query, but yeah, this fails. JSON-B insert will fail if that key exists already. So yeah, exactly. So fine-grained updates, upserts. So here we are using the JSON-B set operator or function. Again, preferences is a column that's relevant, and we're flipping our audio from 1 to 0. And now we see audio is now at 0, which is what we wanted. We're going to add a block ads, which now we've added that configuration. And we're going to also add a hello message configuration as well.
And to clarify the difference between JSON set or JSON-B set and JSON insert is set will either insert or update.
Actually, I'm getting ready to point that out right now.
Okay,
Yeah.
I'm sorry.
No, you're good. No, but that's perfect. So, hello message 1 should be in there, but it's not. And the problem is that we have this false indicator listed. And so, yeah, to Matt's point, JSON B set operates as an upsert, which means it'll update if that value exists, but if it doesn't, it'll happily insert the value, which is what we did for the block ads. You know, that's the default. If you don't want that behavior, which you may not, you may want to have more control over what data gets in there, and you may want to say, no, if I'm running JSON B set, I only want to update, then you want to apply this false flag as well. And so that'll it won't bomb out on you, but it just won't insert any new data into the database. So the query here is we're just going to update actually the nested elements. And so we used to have option A, yin, option B, yang. Now we've got yin 2, yang 2. The thing is, and we left the rest of the column untouched, which is what we wanted. I still haven't figured out how to just do a fine grain insert of saying, okay, I just want to update just the option A value to say yin number 3. The way I have it set up right now is if I were to try to do that, it would actually wipe out the yang 2 as well. And so again, not touching the rest of the column, but within this miscellaneous object, it would wipe everything out, which, you know, sometimes maybe that's not what you want. So I'm sure there's a way to do it. I just haven't figured out how to do it.
MySQL can do that.
Can it? There you go.
We're beating them.
That's
That whole $ dot notation thing. Gets you that by default.
That's cool. Again, I'm sure you can do it in Postgres. I just,
Yeah.
operator error.
It's a little bit more intuitive in MySQL.
Let's see. So if we want to perform some fine grain deletes. So and I think the answer to my question is probably something similar to what I just did here. I just, again, haven't figured out for the update. You know, here we were able to actually just dip into that element and just extract out the option A and the yin 2 key value. So that's pretty nice and pretty surgical. What am I trying to do here? I think here I want to add another option to that. Okay, so now I've just added another option C to this. Not sure why, but it's in my code. Oh, yeah. So here what I essentially did was I used the pound minus and just wiping out the entire miscellaneous object. And so that should be completely gone now. And so I just wanted to show different ways you can delete and different options for deleting some of your data that we didn't show in the syntax slide. And the last set of things of code I want to show for Postgres is just, you know, we've been dealing with objects, but operating on arrays are a little bit different, nothing too crazy. But, you know, if we see this is our username preferences, this is what we have right now. We have a category, an empty categories array that we want to start populating with data. So we're going to use JSON insert. And you see now we have categories of saxophone. And so you just think, okay, these are the preferences for Kenny. If he goes to the website right now, the audio is off. He's blocking ads. The background of the UI is maybe sky blue. And maybe he goes and there's, you know, a category tab for saxophone news and whatnot. And so we're also running the JSON B insert preferences, and then for arrays, you need to specify the array and then the array position of where you want to place said item in the array, and they're zero-based arrays. And so what we're essentially saying is, okay, we want to insert a new category called South Park into this categories array, and we want to put it before the saxophone element in the array. And so what we have now is South Park and saxophone. And since it is an array, even though this is JSON-B and ordering the keys doesn't matter, the ordering of array elements still matter. So that this is actually important. If we want to add another element, we can put it in the one slot. And so what we're going to do essentially here is we're going to wedge gambling category right here. And you see we have South Park, gambling, saxophone. So you would think, okay, when I first ran this, I assumed that this -1 would take this baseball value and put it at the end of the array as the last element. That's not exactly what happens. When you use a negative number, what it does is it goes from the far right element and it just moves back the number of spaces. So it started here and just moved back 1, and so we wedged baseball in here. And the next example where I use a -2,
There's actually patterns in other languages that do that exact thing.
oh, really?
Yeah. If I'm not mistaken, PHP does that, doesn't it? Yeah.
Oh, okay. You know. So here we use -2. And so we went from saxophone to baseball, and then we wedged Barbie into there. And if you want, I mean, this is the best way I know how. If you want to say, no, I want this array element to be the final element, I just took a number that was higher than the farthest element and just used that. And so I don't know if that's, you know.
You accidentally highlighted the thing. You'll have to re-grab it.
And so now we have acting as the final element in the array. And so you don't have to insert your elements one by one. You can obviously insert them multiple at a time. And so here, categories, and then we just inserted an array of elements. And so, you know, it's not fine grained. You know, we just completely clobbered the existing array, but that's what we have there. And then finally, if we want to access some of these elements, we can access the entire array, or we can actually access individual elements based on their array positions. So again, categories, (1) will get us the 1 position. If we were to do 2, we'd get 3, and so forth. And if we want to delete, it's the same deal, using the pound minus, and then you want to specify the position. But this, when you actually, I just want to point this out, when you use the -1 for deletion, it actually will remove, there we go. When you use -1 for deletion, it actually will grab the farthest element and actually remove that. So I'm not really sure why that's different for deletions versus insertions, but it is. Does that make sense, the difference there? And then if you just want to completely crush the entire array, you can just use the regular minus syntax, specify just the array itself. Oops. And then it's completely gone. No, these are update statements. Yeah, this was all permanent stuff that I was running. And yeah, I think that's pretty much it for my code. If you want to show them, yeah.
We'll have both the Postgres code that he just demonstrated and also a MySQL pretty much runs you through everything that's not unique to Postgres. So
Right.
we'll have those available either on Meetup or the Where Matsy Netcode's site has both the slides, and I'll put a link into the Git repo that we're using to store this.
So yeah, there's some of the resources that we use in coming up with this. There are others. We'll have those added as well. Just didn't want to bombard the slide.
My set of resources alone for Postgres or for MySQL, Maria, and SQLite was like 100 links. So
Yeah.
I didn't really want to vary it.
Right. Yeah, and so, for a follow-up presentation, there are more JSON functions that, we could have gone through today, didn't. Indexing is probably the next frontier as far as figuring out how to get the maximum performance from actually querying this JSON, optimizer and query planning, and even database design. I mean, I know we kind of talked through some, simpler use cases, but just as I was, and I'm sure Matt was going through the same thing, just preparing for this, just dealing with NoSQL just kind of puts you in a different mindset. And so just thinking about, okay, well, how could you, and really practically combine the power of the relational database and the NoSQL JSON world. So that'd be something to talk about next time.
And the difference between storing your JSON in a text column to gain some of those benefits versus using the native binary format, what performance gains or losses you're taking
Sure.
would be included in that. So,
Through questions. And yeah, this is our contact information. So yeah, this is where you can reach us. I'm probably most accessible via Slack or even Meetup. And then you have Matt's information. But yeah, that's what we have, guys. So appreciate you guys coming out. Thank you. It looks like there might be a fair amount of food still back there, so please help the cause, help your bellies.